Okay, in this problem, 2 kg block and a 4 kg block are connected by a light string as shown. So here's 4 kgs. The inclination of the angle is 40 degrees. Friction is negligible. What is the acceleration of each block and the tension in the string? Okay, you want to find the tension in the string and the acceleration of the blocks. You want to find two things, so you need two equations, and you'll get two equations by applying F equal to ma to these two objects. Okay. We'll set up the equation assuming that direction is positive. So, and if acceleration comes out positive, that means the blocks are, this block is going up the incline, and if acceleration comes out negative, that means it's sliding down. Okay. All right. So this is the positive direction for this block. This is the positive direction for this block. And let's assume acceleration is like that. And if acceleration comes out negative, that means the blocks are going the other way. Okay. All right. So and remember this is m1g. The component that's relevant is mg sine theta. Okay. So for block 1, t minus m1 g sine theta equal to m1 times a. For block 2, m2g minus tension is equal to m2a. Okay. And we'll call this equation 1, this equation 2. If you add 1 and 2, you can see that the tension cancels. The tension will cancel if you add 1 and 2. And what you get is m2g minus m1g sine theta is equal to m1 plus m2a. Okay. So a is m2. Okay, a is m2 minus m1g. Times g divided by m1 plus m2. Okay, so that's the expression for A. Let's compare this to the expression for the Atwood's machine. So here's the expression for the Atwood's machine. For the Atwood's machine, A is m2 minus m1 divided by m2 plus m1g. That expression is almost the same except for this sine theta factor. And you can see that if theta were 90 degrees, this incline becomes an Atwood's machine. And sine theta, sine of 90 is 1. You get that expression. Okay, so that's a neat thing. All right, so here's the acceleration and the tension in the string. Okay, so now, well, let's calculate the acceleration first. So let's put in the numbers. What are the masses? 4 and 2 kgs and sine 40. So that is the acceleration. And from this you can see that A will be positive in this case no matter what the angle of the incline is. Even for 90 degrees, this would be 4 minus 2 would be 2. That's a positive number. Okay. Oh well, so what that is saying is the only way these guys would slide down is if this mass is greater than that mass. Okay. And even if this mass is greater than that mass, there are angles for which it'll slide up. Okay. All right. Anyway, so the acceleration of the blocks are 4.43 meters per second squared. Okay. And to calculate the tension in the string, what we can do is use this equation. Use the equation for the second mass. Tension is m2g minus m2a. And so the tension works out to 21.5 newtons. Okay. So this frictionless incline is sort of a modified Atwood's machine. Okay.